This video covers topic 19.6, dividing radicals. The Bell Work has asked us to simplify, and when we simplify, this is using multiplication, which is what we did on topic 19.5. So remember, when you multiply, outside gets multiplied with outside, and inside gets multiplied with inside. 3 times 6 is 18, and that would be the same on the inside. Now, if possible, we're told to simplify the square root. 18, as we just said, is 3 times 6. 6 is 3 times 2. So we have the 18 in front, and then inside we have 2, 3, and 3. A pair of 3's would come out, and the 2 would stay inside. 18 times 3 is 54, and the square root of 2 would stay as is. So, today our notes are covering dividing radicals. In order to divide radicals, there are 3 steps that we must take. First, we reduce the outside numbers and inside numbers separately. Then we simply simplify the radical and rationalize if there is a radical in the denominator. Okay? So step 1, or example 1, we can break this up. So we have the square root of 3 over 16. We can break this up into the square root of 3 over the square root of 16. Now the square root of 16 is a perfect square. The square root of 16 is 4. We have simplified the square root on the bottom. We have not done anything with the square root on the top. But because there is no square root in the bottom, we can stop there. So the main goal from all of these is to make sure you do not have a square root in the bottom. Now, part of the problem per se with dividing radicals and simplifying them is there's many different ways to simplify. So you kind of have to be on the lookout. For this first one, 3 divided by 16, if I put that into my calculator, it doesn't simplify anything. Sometimes you can just divide them, but here when we simplify, you can't simplify the square root, so we have to look, can I simplify one or the other? Okay. So problem 2, this is how you rationalize. However, it would be a lot simpler to say 21 divided by 3 is 7. That's the answer that we got. So the square root of 21 over the square root of 3, because they're both inside the square roots, you can divide. Now when I did the notes, I didn't think about that because that's not how my brain works, but that's okay. So a lot faster way would just be to say 21 divided by 3 is 7. We haven't done anything to get rid of the square root, so it's just the square root of 7. But because the square root of 7 does not have a square root on the bottom, we don't have to do anything else. Problem 3, we divide outside with outside. 8 divided by 4 is 2. Inside with inside. 48 divided by 2 is 24. So we're now to this. We have a 2 on the outside, a 24 on the inside. Now 24 can be broken up into 4 and 6, 4 into 2 and 2, 6 into 2 and 3. So we take a pair of 2's outside. So we had a 2, we're bringing out a 2, so that's a 4. And then 2 times 3 is 6 left on the inside. So the only difference here is taking that front part, dividing, the inside square roots and dividing, and then we're just back to simplifying. Okay. Now problem 4 is where it gets a little bit ugly. This 12 is not inside the square root. 2 is in the square root, but we can't do anything with these because they're not the same. They're not both inside or both outside. Now, I can't leave this as my answer because at one point, some old math farts, we don't know who, but they decided that having a square root in the bottom is a problem. So this is where we truly need to rationalize the denominator. Okay? And usually there's only 2 times when this happens. One, when you've done everything you can, but you can't get rid of the denominator in the bottom, Or 2, when the problem looks like this and there's nothing you can do to get rid of the denominator being a fraction, the bottom being a fraction, so you have to rationalize. Now, the way we rationalize is we multiply by whatever's on the bottom. So the square root of 2 is on the bottom. We multiply by the square root of 2 over the square root of 2. Now, we learned a long time ago that anything divided by itself is 1, but I'll show you just to make sure you remember. So the square root of 2 divided by the square root of 2 is 1. So we're not doing anything to change the value of the problem. We're just changing the way the problem looks. So on the top, when we talk about multiplying yesterday, or whenever you watched topic 19.5 or learned about it, outside stays outside, inside stays inside. So 12 times the square root of 2 is 12 square roots of 2, because 12 is on the outside and the square root of 2 is on the inside. Now on the bottom, the square root of 2 times the square root of 2, we learned on the multiplying day that if you have the same number inside and they both have square roots, then that just simplifies to that number without a square root. So the square root of 2 times the square root of 2, remember that's 2 times 2. We have a pair, so it goes outside. That's why. I will tell you that every time you rationalize the denominator, you will multiply by the denominator on the top and the bottom, and the bottom should be that number without a square root. So start looking for patterns like that. Now, I can simplify because 12 divided by 2 works out nicely. So 6 square roots of 2 is what my answer needs to look like. You cannot leave a number like this with a square root in the denominator. On the first example, we were able to get rid of the square root in the denominator. On the second example, we were able to divide and get rid of it. On the third example, we were able to divide and get rid of it. But if you've tried everything you can, but you can't get rid of it, then you have to rationalize. Okay. So problem 5 is another example. We can divide 3 divided by 7, but when we do math in our inner, we end up with 3 over 7. We can try to break it up into the square root of 3 over the square root of 7, but neither of them get rid of the square root nicely. So again, we have to rationalize. Because I've thought of everything I could, I've tried to break it up, I've tried to keep it together, I've tried to divide it, I've tried to simplify the square root separately, and nothing works. So my steps to rationalize are multiply the top and the bottom by whatever's on the bottom. Inside stays with inside. So on the top, 3 and 7 are both inside the square root. On the bottom, the square roots cancel, and I have 7. Now, the top is inside the square root. The bottom is outside of the square root. So I cannot combine these. Inside the house and outside the house are completely different. So that's my answer. Remember, as soon as you have no square roots in the bottom, you can stop. Okay. For the last problem, I'm going to multiply first. So when I multiply fractions, I multiply straight across. Now you can do your alpha y equals 3 over 7 times 14 over 27, and we get the square root of 2 over 9. Okay, remember these are still in the square roots. So I can break this up, the square root of 2 and the square root of 9. In my calculator, the square root of 2 does not work nicely. However, the square root of 9 is 3. So the top has to stay, but the bottom can be reduced to 3. So I multiplied those fractions first to get 2 over 9, and then I simplified into the top and the bottom, because remember, you don't have to rationalize if the bottom works nicely. And so if you can get rid of the square root in the bottom by naturally taking the square root of the bottom, then you're fine. So the square root of 2 does not simplify, but the square root of 9 is 3. I no longer have a square root in the bottom, so I'm good. So remember, your goal with dividing or simplifying square roots with fractions is you cannot have a square root in the bottom of your fraction. You can have a number in the bottom, but not a square root in the bottom. So one thing you want to look at is, can I divide these numbers? If 2 and 9 divide nicely, then you can get rid of it, maybe like we did on the front. The second thing you need to look at is, can I break these numbers up and get rid of the square root in the bottom? On 6 and one of them on the front, that worked nicely. If not, then you have to rationalize to get rid of the fraction in the bottom, the square root in the bottom of the fraction, sorry. So your goal is to get rid of the square root in the bottom of the fraction. That is your end-all be-all. If you still have a square root in the bottom, you still need to keep going. As soon as you get rid of your square root in the bottom, if you've done everything correctly and simplified as much as you can, then you're fine.